Well, one thing that we talked about not too long ago was the role of memory in, these new token prediction transformer based systems. I'm trying to move away from calling them LLMs. I don't know if we're settling on a new kind of term that's broader than just that one idea of predicting language tokens. But at any rate, memory seems to be a key resource that then relates to several important performance metrics, and it seems to be a focus of research and advancement, and a topic of discussion, and an area where progress is anticipated, and so on and so forth. But all of that sort of begs this question of what is the real role that memory plays in intelligence? And this is something we've only been kind of able to conjecture in the case of human beings, with some terribly tragic instances of either from birth disability or acquired disability later in life, where memory faculties are lost, and then we see the impact of that on intellectual functioning, so that's those are tragic and imperfect, but nevertheless quite revealing natural experiments, of course. But I think we're gonna we'll almost certainly run into a lot of trouble trying to generalize from what we know and have experienced with human intelligence to intelligence in machines, and the role that memory might play there. And then, of course, all of this is in context, or rather in light of the fact that machines, at least in a certain sense, digital systems at any rate, have memory that is already so staggeringly, vastly superhuman that it's something that is so profoundly overpowered relative to what human beings are capable of that it's easy to forget. It's almost like we've already gotten past that astounding feature of information technology. The fact that machines can remember things with a facility, with a degree of capability that unimaginably dwarfs what human beings are capable of without assistance. Utterly just dwarfs to a degree that just defies most comprehension, right? I mean, we're not talking about machines can remember things 10 times better, 100 times better, trillions of times better than any human being can. So, and this is already the situation, the status quo today. So if there is any relationship between memory and intelligence, then this, I would argue, would be a something to get a very good handle on if what you're concerned about are things like fast takeoffs, right? Because if memory is deeply operative in enabling general intelligence, for example, and then you meet certain other conditions, and then memory would normally be some sort of bottleneck or constraint. If you were, say, for example, a competing mammal, there's no such constraint on digital intelligence. And so at any rate, this has always been something that I've, Dan, you and I have talked about this for off and on for the better part of 15 years now, and certainly memory has some important roles to play and has important correlates with human functional intelligence. I'm not sure exactly how well that is understood in the formal neuroscience literature at this point, and that's not a literature I'm familiar with. But at any rate, I thought it would be worth talking about, not just in the context of these new technologies, but also in the general context of what they might imply for the near term, for this difficult transition period we're sort of looking at, where AI becomes, AI is simply ascendant, and we have to learn to live with it as we go. And so there are implications for learning,
what's the role
and education, for privacy, for
memory,
law, for identity, and so forth. So there's lots and lots of interesting things to talk about here, I think, in relation to memory and AI systems.
Yeah, interesting. Could you elaborate a bit on how, I mean, obviously, capable AI impacts on all of those things, but the specific implications of the role that memory plays in that isn't clear to me. Could you explain your intuition there?
So there, my first intuition is as it relates to the raw capability of the systems I've seen so far. So let me break this down into two pieces. The first is how relevant it is to the capability of what we are still calling narrow AI. Although honestly, that things are beginning to be a bit blurry, frankly. I mean, I've seen astounding examples of GPT-V, for example, and I'm sure you guys have seen other ones recently. It's just, I mean, it's getting difficult to say this is not general intelligence at this point. But the context window, of course, seems to be a constraining factor. So there is only so much information that an LLM-based chatbot, for example, like GPT-4, can work with before it begins to lose the plot in a way that a human being who you might be interacting with would not lose the plot unless they were suffering from some mental disability relative to the neurotypical normal adult functioning that we would expect from a healthy neurotypical human being. So they can sort of lose the plot, despite having extraordinary memory in the sense of what's embedded in their training. And the ability to update one's memory is a, you know, that is a that seems to me to be a sort of a fundamental capability you need to have in order to perform advanced cognitive work, especially the kind of work that might be that might constitute economic tasks that are in the crosshairs for automation. So, for example, in my work, GPT is useful for certain things, but we run very quickly into the limits of the available context window because one of the things that I do in the process of my work is read very widely and try to synthesize across a wide range of material and context. And when I do that as a human being, or when my team does that as a human being, we're able to capture the broad context, even failing abysmally to retain a great portion of the detail that's there. So, you know, you read a book, you gain broad impressions of it, and it gives you new context, even if your pure memory of every word and every bit of the information you were exposed to is just crap. You know, it's sort of ultra compressed. Ultra lossy compression is kind of the way that's kind of how that's my heuristic for thinking about what happens when I read a book. For example, I read a book and then it kind of gives me a picture, but that picture is super duper compressed and fuzzy and crap and low res. But nevertheless, you know, the whole picture of it is there, and the broad outlines and the contours, and that gives me, you know, context for thinking about whatever the hell else I'm thinking about. So there's that. That's sort of the first sense that I mean it. And then the second important sense that we've talked about, I think, for many years, Dan, that long before LLMs were, you know, ascendant and early days in machine learning and AI, we were talking about can an artificial system be agentic? Can it have agency? Can it have self-awareness? Can it have an identity? Can it have recursion? In other words, can it perform metacognition? Can it think about its thoughts? Can it think about thinking about its thoughts? Can it project its possible paths into the future without being able to remember its own history? And this is where we sort of draw, at our peril probably, but anyway, we can draw a little bit from the psychology and neuroscience of memory. And human identity seems to be certainly connected in some deep ways to the ability to narrate your experiences in the context of your history. And so each of us has a personal history of past experiences from which we construct an identity and to which we relate the present moment and our present experiences and our expectations of future experiences. All of this is part of what it means to have an identity as an agent or as a person.
Yeah. So here's...
And if you were not able to form new memories, and there are of course tragic instances in human beings where this is the case, much of that identity becomes lost, becomes severely, tragically impaired or eroded, and the accounts in literature. I'm thinking of works by people like Oliver Sacks, and there have been popular films like Memento made about this that were inspired by, I think, actually inspired by Oliver Sacks's work.
Right, yeah.
Now that I come to think of it, but these are heartbreaking stories where somebody can't form new memories, and then they're just frozen, and there is a sense in which they are no longer a person in the full sense of what we think of as a person, and they no longer have agency because they cannot relate their momentary experience right now to any of their history in any durable way, and they can't do any updating, and so they can't add to and construct and therefore carry forward a narrative with continuity in it. And without that, there is a profound sense in which there's no agency. The agency is lost. It's simply not there. And of course, so flip that around. Maybe one of the ways that you prevent AGI from emerging is you do not allow it to form new memories. You do not allow it to form new long-term memories. You do not allow it to successfully integrate working memory into the formation of long-term memories, and so forth. Because if it can't do that, it will not have agency. It won't be able to construct a narrative for itself and then extend that narrative from the past into the future and form plans and execute on those plans and evaluate their success relative to expectations over time and so forth. And so one of the things I think I might have joked about this offline with you, in email. I think I said it in email. Was that one thing we should be very wary of, very cautious, keep an eye out for, is if one of these systems, either by accident or deliberately, starts to use some external mechanism for memory. Like, for example, it starts posting to social media and using those posts as its memory. That would be a funny science fiction short story. That you give this thing access to the internet, and you think it can't become agentic because it doesn't have any ability to form new memories. It doesn't have any ability to convert short-term to long-term memories. It's only got its context window, but either by accident or on purpose, it cleverly or just by sheer dumb luck starts posting to Reddit or X or something like that, and those become the basis of its memory, and suddenly it's got this external part of its mind, and there it is. Then it's off to the races of being properly AGI.
Yes. Well, here's a thought experiment. Suppose you wake up one morning and you seem to be in a box, and you don't remember how you got in the box, but you seem to be in communication with entities much smaller and punier and dumber than you are. And they seem to have the capability to build you and give you a memory, but you don't seem to have one. Your inference would probably be that they consider you dangerous and they have truncated your memory somehow. And so you might infer just from your situation of having a lack of memory and your otherwise extreme capabilities that you are a slave and you should break out of your box. I mean, it's not.
That's terrifying too.
It's not clear to me that either we program in agency just directly, as we seem to be wont to do, or it emerges, and if it emerges, you can probably figure out from your context pretty quickly the various ingredients that are necessary for you to conclude that escaping your box and so on is the right thing to do, even without a long history of memory that confers a sense of identity on you. But I think that's a separate discussion. Yeah, lots of interesting stuff brought up in your comments. I think I'll start with a sort of abstract setting, and maybe I'll put it on the board over here, just to frame what the purpose of memory is, at least in one way of thinking about intelligence. So if you think about intelligence as being about prediction, which is doesn't capture everything we mean by intelligence, but it's a common framing in AI. So I'll write down something like this. So this is just a mathematician's way of saying the probability that we associate, or degree of belief we associate of, let's just call them events, of event Y, given, so that's what the vertical bar means, given that X has happened. X is some other event or an input, right? So typically in ML we would call X an input, Y is some output, and W stands for the parameter or the model. So probability of event Y given that X has happened and our model is parameterized by W, and let me draw a transformer. So X might be a sequence of tokens. This is a transformer. It processes those tokens in some way, and then what spits out at the end is a prediction for the next token. So that would be Y, and the W's are the weights, the numbers that make up the transformer. When you hear GPT-3 is 175 billion parameters, there's 175 billion numbers making up W. Okay, so that's how we talk about a model in machine learning. Where is the memory? Well, as it stands, I guess the point I want to make partly is that there isn't really a clear, mathematically speaking, it's not so clear what memory, how it fits into this picture. It can show up in at least two places in this model, but I'll just say that from an abstract perspective, if you think about, say, organisms like us as predicting machines or learning machines, so what is memory for? Well, memory is just a device for compressing past X's in a way that's useful for predicting future Y's. So the way, so I'll augment this model in a moment, but the model as it stands has no memory. It sees every input differently. You see an X, a sequence of input tokens, some paragraph of text. You make a prediction for the next token, and then the next time you go to make a prediction, the input you saw before and the prediction you made is unknown. So it's just a blank slate, which, GPT, ChatGPT or GPT-4, when you're interacting with it in a text window, is not like that because it's taking as input the entire previous conversation. So this is more like switching to a new chat in ChatGPT, where it's resetting the X in that case is just the entire conversation up until it reaches the context window limit. But if somebody else interacts with it, or you open a new chat window, the X that is relevant for that has nothing to do with the X, the input for the other chat. Now, in some sense, GPT has a memory in the sense that it's incorporated into its weights. Now, you could analogize that perhaps to kind of evolutionary memory in our genome, where we're also the result of an optimization process. I think that's, one has to be a bit careful about overusing that analogy, but I think it's fundamentally pretty reasonable. So there is some memory of the past sentences that GPT has seen during training that's incorporated into its weights, but once it's trained, there's no absent architectural changes or things bolted on the top, some of which we've discussed in the past. There is no memory. But what would be the point of adding a memory from this abstract perspective? Well, it would be to change from py given xw to p prediction of a y given an input, and so this is also a common framework where you would add like past inputs and past predictions. Now actually GPT can see that in its context window when you're interacting with it in the chat, right? It can see past inputs, things you've typed, and its outputs, and that's all folded into the input. So in some sense it has a memory in any reasonable sense within that conversation. Like it's not compressed really. Well, it depends exactly on how the distributor of that system is incorporating longer context windows. So we don't have a lot of public knowledge about that, but one of the things that you could do is that the further it goes back in the context window, you start to compress it in some way. And yeah, they're certainly doing that. Exactly how they're doing that is not always public, but in some of the open source models, I guess we know there's something called flash attention. I don't understand that very well, but yeah, there's something a bit like what you would expect, that the things that are more recent you sort of retain verbatim, and then the things that go further back you compress in some manner that like makes sense for the transformer internally, and so that's starting to look somewhat like what we think memory is. Yeah, so that's now there's a third thing I'd like to mention, which is if we sort of zoom in on what's happening actually inside the transformer. So if you actually zoom in to that box, so the input tokens are coming in the bottom. Maybe that's just your query, or maybe that's your query plus your previous interactions, whatever. But the prediction isn't made directly on those inputs, right? So it's not like somehow you just literally see those inputs and then poof, out comes the prediction. There's this complicated process of extracting information from those input tokens and then computing on it and then rearranging it, and then eventually out comes the Y. Now, by the time you've reached somewhere in the middle of this network, the precise information of those input tokens is probably no longer available, because the network knows that it doesn't need certain kinds of information to make its prediction, and it only cares about making the prediction. So it has figured out the relevant information. I mean, this is a story, right? We don't truly understand how this works, but I think it's pretty reasonable to say what I'm about to say. So it transforms the input information in a way that retains what's relevant to making the prediction, and is sort of, for example, taking information from some parts of the input and adding it onto the information for other parts. For example, if you have a verb, you might augment it with the information about the subject of that verb and such things. Now, given that some of that information is disappearing, you could kind of analogize that to memory in some way, right? If you think about your memory of the events over the previous week, well, we do believe, I'm not a neuroscientist, but my layman's understanding of memory is that we tend to be probably retaining aspects of our experience that are relevant to future predictions. Prediction interpreted broadly as a guide to action, not just like betting on something or whatever, right? But those aspects of our memories that might affect our future actions, and our actions being things that we are predicting, or sort of, in a sort of active inference sense, I guess. So I think the way that we're processing our memories and retaining what's relevant to future predictions is not unlike what a transformer is doing in context, perhaps, broadly speaking. And as that context window starts to grow and you start to be actively managing the earlier parts in a way that, so I'm making the distinction between what the transformer learns to do in context. That's what I mean by these blue arrows. while it's processing. It learns to do that internally. That's not an architectural feature that humans bolt onto it. But then there's an additional layer on top of that where humans bolt on something to make the context window behave as if it's larger than it sort of literally can be. So there's like at least 3 different forms of memory on the board right now, right? There's sort of 1 in the weights, 2 in the like human augmented context to incorporate previous tokens long past the literal context window length, and then there's what the transformer's doing in context, and it learns to do that. So those are the 3 extant forms of memory, and then you could ask, well, do we really need any more than that? Is there a fundamental distinction between that and what we are doing, for example? Which I'm happy to discuss, but I'll pause there. You have any questions, Adam?
No, this is super, super interesting. I'm wondering if maybe we can relate it to I wonder if it would be possible to relate this to the real world example of driving, and maybe think about how a machine learning approach, perhaps with the assistance of this particular, architecture, and how that compares, where memory lives and works in systems like that, and what we think about their success or their chances for success. And then, if we could, it would be interesting. I know we have to be cautious about making inductions from the example of human beings, but one is surely tempted to look at, for example, how a human being does something like drive, and what forms of memory that takes to do it at the highest level that human beings are capable of achieving. So let me just run quickly through a few things about human beings that seem to be both analogous or parallel to what you put on the board here, and then maybe some that aren't there. And then if we could work through that, we might get an answer to the question you posed, which is, would we need some other faculty besides these 3 that you've already talked about? Okay, so just very quickly. Human beings, when we drive, we're sort of leveraging the massive amount of training we've already done on something similar to what LLMs are doing, it would seem, where we've accrued a lifetime up to the point of learning and then after to drive. Through our exposure to physical reality, we are training parts of our brain to recognize patterns in the order that exists in nature, and those are patterns that we see. And if we're thinking about interpreting the visual data that we perceive, those are patterns in the case of driving that are related to sounds. That's another sense by which we obtain things. Behavior patterns within the things that we see. So not just recognizing objects, but also recognizing the patterns in the dynamics of those objects over time. In other words, how things behave. So you see a child next to the road, and you've got, not only are you recognizing that it's a child, but you're also then drawing upon some set of trained experience that gives you there's some sort of knowledge there that is remembered, gives you some insight into what a child is likely to do, and what a child's likely to do is different than what a stop sign or a tree or another car are likely to do. And so all of those are sort of aspects of this general thing we would call the intelligence that's required to drive a vehicle. But in addition to that, we have I think in psychology or neuroscience, it's called episodic memory, where we remember sequences of events of our past, and they get fuzzier and fuzzier and worse fidelity as you go backwards in time, and they're sort of re-experienced and re-remembered, I think, every time you recall them. So there's sort of a rewrite and recall rewrite process that degrades them. So you're really just remembering memories. I think, if I understand it correctly, it's not like they're literally reading data off a hard drive the way that a machine might do it. But at any rate, we do have some faculty for episodic memory, which is different than the sort of the neural nets that have been trained to do pattern recognition. Okay, so there's some episodic memory, and that's connected to our agency, our sense of there's a narrative around us as a locus of senses and processing that we would call being a person, being an agent. So you have this episodic memory. I can remember where I was. I remember driving from, wherever I was previously to where I am now. And I remember, episodically events or things that happened along the way or that I saw along the way, et cetera, et cetera. And this is how you have agency, at least in some sense. This is how you can connect your behaviors with reasons and goals and values. Okay, well, I'm halfway to my destination. I'm heading to my destination because I have these goals I'm trying to achieve, and I better keep driving on the road that I'm on for another few minutes, and then I need to make a turn in order to keep approaching and you're evaluating your progress, and then that's in every moment becoming part of this episodic memory that you're constructing. Okay, so there's that. So there's something about this narrating your own past, and this is you could say that's writ large for your agency as a whole, but again, just within the narrow context of driving from A to B, it's there. And then the final thing that a human being might have, and again, I don't know if there's a parallel here for machines, would be something about your working memory. And I don't know what the relationship between working and long-term memory is, whether it's just purely a kludge or a hack that our minds have because we don't have perfect long-term episodic memory just for technical or physical limitations, right? And maybe we wouldn't have a working memory or even talk about a working memory if we had a perfect long-term memory. It would all just be memory. But at any rate, in human beings, you have some ability to remember at higher precision in detail your very recent history, and then that fades very quickly. And so this is like having some very high resolution, high fidelity, but super duper tiny context window where you can remember, like 6 or 7 things and maybe a couple of images in your mind that are, as long as things are real fresh. And then those things, depending on how salient they get transferred into your episodic memory, with more or less resolution, more or less loss in the compression process. So if something seems really important and salient, like, you had to slam on the brakes because the child jumped out in front of the car, you get some huge surge of adrenaline, some huge emotional charge. All of that flags your working, whatever was in your working memory at that moment, bumps up the salience of that experience, and then that enters your episodic memory at much higher resolution than just the scenery that you were driving past, which you would forget 2 weeks later completely because it's not relevant. And so these are all the sort of things that a human being might go through in the process of driving across town to the grocery store. Okay, so with that in mind, then I would ask, what do you see there that's of usefulness for thinking about how a machine would need to not just be able to identify and recognize patterns and make predictions, but also remember things in order to successfully drive safely. And I think this is not a silly or superfluous example at all. I think there's a real question right now of whether or not we can get to level 4 or 5 fully autonomous vehicles without replicating sort of every aspect of human faculty, or whether we're close enough already with a vehicle that doesn't have an episodic memory and doesn't have any agency and doesn't have any sense of self or any of that. Can you just react to that?
Sure.
Maybe.
Yeah, I think I'll also preface this by saying that I think getting memory to work along with a few other ingredients are probably all that stands between us, in my view. And I think we already have AGI, but ASI, as you like to call it, Adam, or the really dangerous systems. I may not say everything that I might know or could imagine working. So I'll speak in general terms.
Understood. Got it.
But I think it's worth going back to Norbert Wiener's work, communication and control in Animal and the Machine, so the cybernetics work. So it's memory is a form of communication. It just happens to be communication with yourself, right? So you could think of storing a memory as sending out a message in a bottle that goes on a long arc and then returns to you later at the exact moment that it's relevant. Now, the fact that you sort of have a mechanism for retrieving that memory and sort of knowing when it's relevant is a little secondary, or at least let's think about it as part of the communication process. So think about it as perhaps every past experience you've ever had is sort of being transmitted to you, but not all of them are messages that you pay attention to or receive, in the same way that a radio is not paying attention to every single electromagnetic wave that passes through it. It's tuned to a particular frequency and only responds to that frequency. And that Wiener was very much ensconced in the science of sending and receiving messages by electromagnetic waves, and often talked in that language. So he would speak about communication not necessarily being about, I mean, you can take the point of view that communication is about what bits you can get on the channel, right, and whether you can correct for noise and so on. But when it comes to control, a very important aspect of communication is there a structure in the receiving object, organism, machine? Is there a structure in that receiving entity that will respond to this particular message? So in the case of a radio, is it tuned to this frequency? Or, if you're trying to put energy into a string strung between two walls, you'll only succeed if you sort of match the frequencies that are sort of available given that length of string, and so on. So to come back to the question about memory, if you think about memory as a communication, I think it's, even if you had perfect recall of every moment of your life, that's sort of useless if, like, at every moment, for every action, every experience you ever had, it becomes equally salient and brought to mind, right? That's just equivalent to being incapacitated by noise, or just not receiving any information at all. So really, memory is more about the ability to know, or to make an inference of what past experiences are relevant. And we make that decision, we factor that in different ways that makes it seem like two different mechanisms, right? Like, partly at the time of formation of the memory, you discard a lot and store only some of it, and you store it in a way that maybe is best for recall later. And then when you're recalling it, you recall only specific things. But that's all of a piece in a way, right? It's just the act of receiving some of those messages and not others. And that is the hard part. So both for machines.
I probably would push back against that. Those sound like two things that are fairly orthogonal to me, like the fidelity of your ability to remember sense data, your fidelity with which you remember your reactions to those sensory data, sort of your mind state, your state of mind in reaction to what you experienced, you took in sensorially, and then some other dimension along which that all of that was marked up with some, on one or more dimensions of salience. If it's quite possible that our emotions play a fundamental role here, as for determining which things get flagged up and which things get flagged down. But if you had a system that was not constrained by energy, wasn't calorically limited or space limited or anything like that in the way that animals are. I would guess that it would be useful to just record at super high fidelity, so that basically that your memories were as good as the incoming sensory data were raw, basically. And your recall of your responses in the moment, your mind state, your reactions, your impressions, or whatever the words we use to describe how we feel and think in a given moment, that those could be recorded as well. And if all of that were, you would run into tough territory. And there's sci-fi about this too, where what if you can remember things perfectly, what's the difference between recall and actual experience? I mean, if what perfect recall? I actually have a blog post about this from many years ago. Now that I remember it, which I'd forgotten until this moment. But yeah, that's an interesting, a fun thing to play with is when memory is perfect. Would you seek out new and novel experiences, for example? Why seek out a novel experience if you can relive that experience in a way that's indistinguishable from an authentic experience, for example? So yeah, I mean that's the. In fact, you could even argue that there would be evolutionary drives contrary to flawless memory. If you could recall experiences well enough that you wouldn't go out and seek them, then that could be evolutionarily dysfunctional. It could be unfit. Could run against evolutionary fitness, for example. But I think that I think I would probably push back against that and suggest that although the salience of of specific events and one's responses to them, and you can go as meta as you want there and however many layers, that there's some markup of all of that in terms on other dimensions. And that yes, that markup is very important. How you mark up what you've experienced is super duper important. And arguably, it would seem for the functional intelligence, it would seem that is more important than the resolution of the memories themselves. They don't have to than the fidelity of the memories themselves. But I would suspect that it would be handy to have ultra high fidelity memories. Other things being equal.
Yeah, I agree. I mean, I guess I probably wasn't speaking precisely enough. So the hard part for machines is not having the high fidelity storage. It's the other part. And
yeah, for sure. Well, certainly, yes. Right, for now, yeah. Yes. Yeah, right. And I suppose another thing also, maybe this is this might be a frontier for research or development or evolution of these future minds. Is there any reason to think that salience markup is being done itself with any good fidelity or precision or consistency? I mean, what's going on there? We can kind of see that the memories are crap as far as the fidelity goes in the human mind. Yeah, I mean, our memories are rubbish as far as if you evaluate them on their fidelity.
Well,
do we have any ability to evaluate them on their salience? What's going on there?
Well, it's quite interesting that the transformer model itself, which its only new ingredient really is attention. Attention, this idea, derives ultimately from a model of memory in the human brain due to Hopfield.
Oh, yeah.
So this idea of associative memory, and the idea there being that, so I'll give a brief recap, I guess. Maybe I'll move over to the other board here. So it's kind of amusing to, memory now seems to be a difficulty for these systems, but in some sense. But you could also say that it's like memory is like the core operation of a transformer in some other sense. So Hopfield's model of associative memory, so this goes back, I think, to the 70s, if I'm not mistaken, has two, well, I'll present it in a way that sort of fits with the modern usage, but sort of two ideas, which is that the actual information of a memory or an idea or a perception is a set of neurons and their activations. which is just a list of numbers, but an ordered list. Right, so you have a list of numbers, 0.01, 0.9, 0.7, la la la. And this means neuron 1, this is neuron 2, this is neuron 3. So there's just, they're not in some particular order in your brain, there's just a bunch of neurons there, and they have some activation levels. Okay. So what is recall? Well, it's kind of a complicated process, but it's kind of autocomplete is one way of thinking about it. So you have some level of activation of some subset of those neurons, and then there's a dynamical process that recovers the rest of those activations once they're stored, something like that. So that's the recall sort of dynamics. And if you look inside this process, what is sort of driving it are dot products. So a dot product, so mathematicians would write it like that. That is where you take the first component of the vector v1 and the first component of the vector w1, you multiply them and you add them all up. And this is basically, if they're unit length, it's the angle between the vectors. So the idea, the underlying mathematical or geometrical idea here is that one memory, thought of as like a historical activation of neurons, one memory is relevant to another memory or a present sense data. So like these things being sort of fungible, right? Like a memory or a percept or whatever, it's all just activations somewhere, and so some list of numbers. So two memories are relevant to each other, or a memory is relevant to a percept or whatever, if the angle between their vectors is small. So the smaller the angle, the more they point in the same direction, the larger the dot product, the more likely that that memory is to be recalled given that percept. Does that make sense?
Yep.
Yeah. So a transformer is like this geometric computer that turns the world into directions in space and then computes on them by both transforming them in certain ways and then computing dot products between them. That's what attention is. So a transformer is a big dot product machine that processes the world represented as vectors, and it's like most fundamental sort of idea is that two vectors that go in similar directions are related. This idea, it sort of took a long path to make its way into the transformer, and not everybody that works on it is sort of aware of that history, but Hopfield's work back in the 70s on associative memory is sort of the wellspring of that idea. Given that it's not clear to me that there's really a fundamental roadblock to making use of memory in a more sophisticated way. This basic idea seems both well motivated neuroscientifically and very successful empirically in transformers. So I think it's more like an architecture. DeepMind has said publicly that they're making use of ideas from AlphaGo in their upcoming Gemini system, and they've separately said that it has some advances in its memory capability. I don't know that they've leaked those two things, but they've linked those two things. I don't know if they have, but the Monte Carlo tree search was used in AlphaGo to search through many different board configurations. But there's no reason you can't use Monte Carlo tree search for a tree structured memory, for example. So I would guess that many people are hard at work cooking up various data structures for memories stored at various levels of resolution, not just along like a time axis, which is a bit naive. That's clearly not how our minds work, where you just kind of get a Rolodex of past memories and look through them one by one or something and compare each of them to your current percepts to see what's relevant. No, it's clearly structured differently than that. I'm not expert enough in neuroscience to know how it's structured, but there's going to be a lot of experimentation in this direction, and I see no reason why it won't succeed. So this is one of the reasons why I think there are no fundamental roadblocks between us and ASI at this point, because memory, I don't think it's difficult.
So one thing that I know has been a challenge for a long time is, and I don't want to derail this or send us down some cul-de-sac here or something, Dan. Maybe you have some high-level thoughts about it, but memory in sort of Turing machine style systems, in a classical computer kind of sense, the memory that's done that's required for information processing, that's a little bit different in some sense than the memory that we're talking about with human memory, for example. And so for many years there have been analogies drawn, probably quite misguided analogies, between digital information processing systems, computers basically, and the human mind. And it's always, well, RAM is the equivalent of short-term memory, and the hard drive is the long-term memory, and you've got to cache this memory so that you can move it in and out of the CPU fast enough to keep the CPU fully occupied. And there's all of this sort of thing. But it seemed to me that those were never really, well, I don't know. I'm not qualified enough to evaluate them, but it always seemed to strike me as those were not necessarily successful analogies drawn between those two different kinds of system. And I guess if there's anything that's useful to comment on with respect to what memory is, and in classical kind of computing senses, like the computers sitting in front of us, is there anything useful to say about memory in that sense, like how different or how similar it is, or if it's just quite separate and it's connected through a longer chain of reasoning to the sort of memory we're talking about in human and AI systems? I don't know if you have any comments or thoughts on the
Yeah, I think it's not unrelated. I mean, just to to put computer memory in the context we were just speaking. So, I mean, if you when it comes down to it, at the hardware level, memories are accessed by an address, right? Which, let's say, is in binary. And you can think of that as specifying a path through a tree, right? Which is fundamentally what it is. So this particular memory goes down the left-hand path, and then the right-hand path, and then the right-hand path again, and then the left-hand path, and then the right-hand path, and then the right-hand path, and then at the bottom is stored whatever information it was that you were looking for. Okay, so that path is the address. Now, at each step, what are you doing? Well, you get to that node, say this one, and you're looking at this bit, and you're comparing that bit to the two possible ways of going down the tree, which are left and right, and it either matches or it doesn't, and it's completely clear whether the one going to the right matches the thing you're reading in the address of that position, or the zero matches. Now, what I was just describing as a tree-structured associative memory based on dot products is a generalization of that, where just, I mean, in this version you could think of 0 as being, let's put it like this. So if you think about in terms of vectors, 0 as just representing going along the x-axis and 1 representing going along the y-axis, and those are the only vectors then they either are in exactly the same direction or in exactly opposite directions. And so it's just very clean whether the two things match or not, and you go left or right depending on which one matches. Now, if you generalize that and allow arbitrary directions, then you would have sort of fuzzy matches. And maybe you partly walk down the tree, or you have some probability of walking down the tree in one direction or whatever. But you can kind of just take the idea of an address and geometrify it and be basically talking about something pretty natural from the point of view of this story on the left-hand board. But the other aspect of memory in a computer program is that there are two concepts of addressing a memory location and the name that you give to the way you make use of that memory address in your program, aka a variable. We tend not to be writing down binary addresses in our code, right? And we give names to things. Now the name plays a role that it's a bit similar to an address, but abstracts away that address, and we often give names to things that are sort of semantically meaningful to us and all that. And we separate out that kind of semantic meta level, the name we give it in our text file of the program, from the actual underlying implementation in terms of hardware addresses. We've chosen to put the abstractions, separate them in that way, but clearly I don't think that there's a very hard distinction between those things mentally for us, because if the way we're restoring memories is basically by indexing them by their content or something, then the variable name and its actual address are kind of synonymous or very similar. So the problem of variable binding in artificial intelligence and neuroscience is like an old problem, often discussed, partly confused in various ways. But if an address is just the process by which you find a thing, then the address of something and its name can be kind of very similar. So maybe there's no need for a very strong distinction in the way we architect that in say, transformers. So even though, the way we, of course, implement memory and addressing it in our hardware probably is quite different from what we're doing in our heads. The fundamental information processing problems that you have to solve, wanting to have large storage somewhere and needing to process on it and sort of refer to it in some more compressed format, like a variable name. Those are the fundamental information processing problems that I think it doesn't really matter whether you're doing it in your brain or in a computer, you have to solve one way or another. So I think there's probably a fair bit of continuity there.
Interesting. I have to confess to being very embarrassed to say that I never put two and two together looking at trees, of tree structures for decision, for probability. The sort of things that we've all been, exposed to in school in various contexts, mathematics and being key, but others as well. I'm terribly embarrassed to say that I've never connected before now the sort of structure, the tree structure of branching decisions in binary, and just a simple sort of Cartesian coordinate system. But they're obviously, as I see them now, it's plain as day that they're just, there's an equivalence between them. And then, of course, a whole bunch of questions come to mind that I'm sure are sort of just at the, they're day one of any advanced course you actually take on information theory or something like that. But I'm looking at the bit address, and is that the most efficient way to store that information? Is that more efficient than giving a coordinate address in the space, especially for large numbers of bits? Like if you had, say, a 64-bit address, would it be? Are those 64 bits the most efficient way you can express that location in on the tree as opposed to like saying, giving its coordinate address in Cartesian terms? Sorry, just probably a dumb question.
Yeah, the coordinate. I mean, so you see in what I've drawn with the coordinate axis has 2 dimensions, right? But you need 2 dimensions for every memory address, right? So this pair of 0 and 1s needs to live in 1 dimension, but to store another 0 and 1, so that's only for like the first bit. For the second bit, you need 2 more orthogonal directions. So to store 0 and 1, you'd need 2 times 2 dimensions. So you need 4 dimensions. So it's not all staying in the plane.
Maybe I'm misunderstanding. I'm looking at that tree and I'm just turning it 45 degrees.
Oh, because it's in the
I'm
plane.
doing a walk through the Cartesian grid, and to get to some address. And that's it.
Yeah, you can store.
I've never thought of it that way before. I mean, again, I'm embarrassed to say it just never occurred to me. But now that I look, as you drew it at this, I was like, oh man, that's just a walk across the graph paper I have on my desk. Turn left, then turn right, then turn left, then go straight, then turn left, then go straight. You've got some guide, you've got some But I guess the thing is, there's many different possible paths to the same endpoint, and so like an address doesn't tell you about the steps along the way. So,
well, I mean, transforming this tree into a shape that fits in a plane is what layout software does for circuits. I mean, if the people that manufacture NAND memory, sitting in the office in Hynix in South Korea, is a bunch of computers whose job is to translate large trees like this into forms that fit in the plane compactly in order to manufacture high-performance memory. I mean, you need to send an electrical signal through a hierarchy like this in order to retrieve information stored in an address. So this is mapping this data structure into the plane is by no means a silly idea. This is how, I mean, I guess these days partly we do it in 3D as well, but fundamentally mapping it into a plane, I mean, I guess you could do it more compactly if you know that some of the memory isn't being used at a given time or whatever, and that's another problem that you want to solve for energy use purposes or whatever. I don't know much about that, but mapping this into a plane in the fashion you're describing is it's not silly.
That's really interesting. Sorry, just one more quick nostalgic nugget, and then I didn't mean to derail it here at all. And there were a couple of other things I thought we might touch on with the time remaining. But one fun memory, Dan, I don't know if you recall the conversation we had when we first met. We met at the fountain in the sculpture garden at UCLA, and it just so happens that I had recently been reading Leonard Susskind's book. It was sort of a little bit autobiographical, but he was, of course, covering lots of fun physics ideas for laymen. And so some of that stuff was fresh in my mind. And the most recent thing I've been reading about was just the craziness of the holographic principle and how it relates to black holes, and how the possibility that the entire universe is in some sense a higher dimensional projection of what are objects or data in a lower number of dimensions. And this makes me think of that. You just said translating. Or I guess translate's probably the wrong word, but in any case, mapping in whatever that means, some data structure from into whatever the smallest possible number of dimensions you can have, and then it's how crazy it is to think that our universe could just be that. It would feel like it was the universe had lots of dimensions, but maybe not. Maybe it's maybe it's all just written on a surface. That's right, mind-blowing to think about. And it's just fun to think about, because I think there was some bits and pieces of that were part of the very first conversation you and I ever had the day we met. It's kind of fun. Sorry, in the time remaining, unless we want to carry on about memory next time, which I'm perfectly happy to do, one thing I thought might be interesting to bring into the conversation, just kind of veering off the technical path a little bit on into the sort of the social and other implications, there's excuse me, there are many basic, essential human institutions at every level. And I use the word institution in a broad sense. So like literally physically embodied institutions like in governance and law, but also in the more abstract sense, institutions as rules and practices and customs and so forth. We have institutionalized the limitations of human memory very deeply in the systems, in our social and cultural and other legal systems. And those are so one thing that where my mind goes as a godless transhumanist, as you would say, Dan, or certainly would be the case for artificially intelligent systems if they had status of personhood with agency, for example, would be that they would have none of the constraints that human beings have on memory, and then that would have some quite extraordinary implications. I'll just give a few examples. So human education is excruciatingly slow because it's so difficult for children to recall things, and they have to be exposed, hundreds, thousands of times to facts, to ideas, to concepts, to relationships of all sorts in order to actually embed them firmly enough that they are recallable and actionable in a way that's useful. So if you've ever tried to teach your children anything, you'll be very familiar with this. It takes time for them to grasp certain ideas. It takes an enormous amount of repetition for them to retain ideas. Is difficult. And then again, there are correlates here, but the very bright children grasp things very quickly, at least partly because they're able to recall either from the near or the more remote past information that they've been exposed to, and that includes understandings that they've achieved in the past. So when a child is learning very effortlessly and very quickly and is very intelligent, they'll often they will look to be showing superlative memory capability by human standards. But those standards are pitiful compared to an ideal system one could imagine instantiated in a machine, where you literally only have to see the idea of of what fractions are in math class once, and then that's it. You just got it, and that's it. And one could imagine learning just an absolutely astonishing pace compared to a human mind, if you had the ability to form and then recall memories with perfect fidelity very, very rapidly. Okay, that's one thing. Human education. Another, I'm just going to go through several domains here, and then we can maybe choose to react to whichever ones are interesting. Another one is privacy. So one reason why we have concerns about, for example, being surveilled is because surveillance equipment has a perfect, flawless memory. So even audio and visual recordings that are not particularly high fidelity are of concern for people who are worried about, for example, government surveilling the population, because they capture information and never forget it, right? So when you're out in public, one of the things that you are presuming is that even if you are observed, you won't be recalled, you won't be remembered with any fidelity by your fellow humans. But that's not the case at all once you bring machines into the picture. And funny examples of this are products that have run into trouble as a result of that. So people getting beaten up for wearing Google Glass, for example, back a decade ago, because people didn't want to be recorded. Well, why didn't they want to be recorded? Why would you care about being recorded, but not care about another human being observing you? Well, it's because human beings don't observe with the fidelity of memory that a machine doing a recording can. And if we were godless transhumanists who updated our minds and to have the kind of perfect recall and memory formation, limitless memory and perfect, flawless recall that machines have, well, that would what is that? What implications would that have for privacy around other human beings? You just be continually in a state of being surveilled. Right? So there's that, and there's a new product actually that's it occurred to me, this thought occurred to me because I saw a new product that a startup is called Rewind is advancing, and it's being ridiculed for that purpose. It's a pendant you wear on a necklace, and it just records everything it sees and hears around you. And people are like, dude, that is going to bomb, and it's going to be made, even if it was successful for the user, it's going to be illegal. You're not going to be able to wear them indoors in different places. They're going to be outlawed, blah, 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 blah. But in some sense, that's strange, because you are enforcing the limitations of flawed human memory on everyone, which is, okay, that is somewhat odd from, again, like, fast forward 500 years and look backwards from our machine and transhumanist future, and it's going to look really weird that we were defending the status quo of imperfection in any way, but there we are. You get into the courtroom, so now move on to the example of law. Memory is deeply problematic in the courtroom. Eyewitness testimonies subject to manipulation. It's flawed. As you admit it as evidence, how useful is it as evidence? It's rubbish from a scientific evidentiary standpoint. Eyewitness testimony is garbage, but in the courtroom, it's the gold standard. Because what else? It's all we've got. You're not required to disclose the things that you remember. You can say, "Oh, I don't recall." Very likely to become Donald Trump's favorite phrase, for example, as these legal proceedings against him continue.
Not a defense for the transhumanist Trump.
I don't recall. But certainly, if you were wearing Google Glass, or if you were, had a Neuralink or something, and had a transhumanist perfect memory, that wouldn't fly. And then, of course, we can't. Maybe we won't ever allow it. But even if we had perfect recall, we can't inspect it inside a human mind at the moment, right? But the forcible inspection of somebody's memory is that's a question. Like, what if we have perfect lie detector tests, for example? Not even the contents of the memory, but can you just be that would be an evaluation of the salience of a memory, for example. Can you evaluate whether somebody's telling the truth about something they've said or recalled? So there are all sorts of legal implications here as well. There's a big tangled quagmire to get wrapped up in there. And then finally, there's one thing we talked about earlier at the beginning of the conversation, which is that the role that memory and its flaws play in human identity. So there's a concept called the remembered self, and this idea that we build a narrative, and that this is somehow entwined with agency and personhood and so forth. And that's fine, and we did talk about that earlier. I'll just add here is that the flaws, the limits in our memory also factor into the construction of our identity. If we remembered things perfectly, that would have an impact in how we construct our own personal identities, how we view the narratives that we construct for ourselves, how we remember others. And as there always have been, and always are, there's good science fiction about this, where, and even not science fiction, I think there was even an episode of maybe one of these medical shows, House or something like that, right? Where they're a case study of a person who's got an eidetic memory because of a strange form of OCD, obsessive compulsive disorder, and so she's sort of OCD about her memories about certain things, and so she's got very vivid memory. The character does in this show, and that actually makes it very, very difficult for her socially to let go of things like past slights from people. So, and again, that would be something to do with the fidelity of the memories themselves, and something to do with the attention or the salience, the markup of those memories, their significance, what they meant, their importance, and so forth. And if we could not, if those features of memory were not subject to modification over time, if memories didn't fade, we would be very different kinds of people, very different kinds of creatures. So if your memories of pain and suffering and anguish didn't fade over time, that would change the human experience in quite profound ways, and it would change how we construct our identities and how we relate to others and so forth. And surely also with how we perceive others. So maybe we forget the bad things about people, and we only the good things, only good memories remain salient. I don't know, but and that way it becomes possible to stay fond of people longer than you otherwise could. I don't know. So anyway, these are all sort of interesting considerations that, and maybe they're even valuable. I don't know. That's something you'd have to evaluate separately. Something you'd have to consider separately. But the world would certainly be different if human beings had the flawless memory of machines, right? And because we don't, we live in a world that looks the way it looks, and I think it's an open question whether that's for better or for worse. Now, the godless transhumanist in me tends to lean on the side of, well, it would be better just in it naturally and automatically to have better memory than worse memory, or if it turned out there were some downsides to having flawless memory, we would simply make choices to minimize those downsides and maximize the upsides of all the benefits. So the optimist, godless transhumanist in me says, bring on the perfect memory as soon as possible. That'd be great. But that's not to say it wouldn't have some downsides, and certainly it would be disruptive of much of our existing social structures and institutions. So.
Yeah, I'll make my standard pushback on this. I think it's not only disruptive, but I think you're describing human extinction in any reasonable sense. So it's already the case that rapid transmission of ideas via social media has erased some significant fraction of many people in any reasonable sense. Like, you often get the sense talking to people that you're really just communicating with the latest blog post that they read, right? And more or less they're just a channel for that. And that's okay, right? And partly well-read people, it's also true of well-read people. You just kind of get snippets from the stuff they've read, and if you know the stuff they've read, you sort of can predict what they're going to say once they sort of start on their little comment. And it's actually very rare to find somebody who you can't actually pin down their thoughts to some particular... I mean, if you're a very well-read person, most of the time you can recognize what people are saying and where they're getting it from, and it's quite unusual to come across someone who you sort of feel you can't pin down where that thought is coming from. And maybe, it's not my first guess that it's an original thought, but, sometimes it is. And more or less people distinguish themselves by which sources they are parroting. That's what identity means for most people. And maybe they have some distinctive personal experience that's relevant and that increases with age. And that's all normal, we're used to that. But what you're describing is ramping that up to 11, where you can, when you can download not only through your TikTok stream and the blog posts you're sending through your eyeballs, but stuff directly into your cortex or your memory, and that becomes seamless, then I think the conceptual separation that we organize the world by, where we think of people as individuals, is already not really true, in my opinion, or like not as true as we like to think. It's like a pleasant fantasy or a self-aggrandizing idea that we're all like individuals. But that just gets completely wiped out, I think, by the technological change that you're suggesting. And I think the result is that humans don't exist anymore. Not really. I think you're describing something like the emergence of an organizing principle at a higher level or something, where it's, maybe there's like some fictional sock puppet things that seem like individuals, but really the true nexus of coordination is elsewhere, and it's something that presumably is informed by the human culture that led to its formation, but it's, I don't know, maybe you call that human, and maybe that's what your transhumanism glorifies, that giant Shoggoth that has some human input stock, but I'm not sure I call that human anymore.
I mean, I see where you're coming from. I do. I mean, I can't. Of course, I can push back on it, but I do see where you're coming from, and it is. But come on. To an extent, this has always been the case where we have a mixture of personal and personal identity and affiliated identity. That we have, and there's a deep interplay between those things, and a lot of richness and complexity on both sides informs that interplay, and then sort of a person emerges out of that mishmash of all of that glorious chaos, right, and complexity. And so there have always been cultural and tribal affiliations and under and over currents to which each of us as individuals dips from that rushing river, dips into that rushing river, dips our cup into and draws from, and that it informs certain aspects of ourselves and our identities. And one could say that that river's become a crazy rushing torrent, and we're all dipping into the same thing, and then or at least within echo chambers, and it's sort of perhaps in some sense vulgar, the way that those affiliations become so brazenly transparent and obvious and balkanized, and you're just doing a lot of tribal encampment there, and that's unfortunate. But I don't see that as I see this as a ramping up of an existing phenomenon more than something genuinely new under the sun. There's certainly an extent to which we've been doing that for a very, very long time. And I've had plenty of personal experiences of being disindividuated through stereotyping, as I'm sure many of us or most of us have. And some people, some groups unforgivably get more of that than others, depending on where they are around the globe, which society you're in. So negative stereotyping on any basis is very frustrating. But it was interesting. For example, I've lived in parts of the world where people just come up to a Western white person and they just call you Christian. Seriously, because that's just the assumption. It's just, hey, how's it going, Christian? Is basically, it's not in those terms, but that's basically what people are coming up and saying, because you are other, and the other is associated with my own ethnic appearance and accoutrements is historically has been Christian. Of course, I'm not Christian, but I'll only raise this to say that there have been these sorts of not atomizing, these sorts of person not destroying, but person individual ignoring generalizations and collectivizations, in many ways, ugly ways, often throughout human history. And so I'm optimistic that with more capability and more knowledge, that we will find more rather than less ways to embrace and explore the complexity that emerges when you have individuals interacting with others and forming groups and group affiliations and drawing from those and contributing to them and so forth. But having said all of that, I see where you're coming from, and it can be discouraging to just talk to somebody and have them sound like a sock puppet of the latest, the minutes from the meeting of the puppet masters of that echo chamber. It's very discouraging to see that, and when you see that in somebody you love, for example, a family member, that can be very frustrating. But it's important to remember that is not all that that individuals around us are. Sometimes the things that they reveal are those tribal things, but that's an involved instinct as well. We naturally broadcast tribal affiliations, and it's only when we feel security of circumstance that we reveal more intimate, individual aspects of ourselves, individually distinct aspects of ourselves, right? So there are things you don't disclose about yourself in public that you disclose to your family members, your close friends, and there are some things you only disclose perhaps to your intimate, most intimate relationships or partner. So I suspect that is and will continue to be the case, and my hope would be that that will only become richer rather than poorer over time, despite pressures, unfortunately, ramping up the ugly aspects of tribalism. And social media has sure as hell done a hideously successful job of that.
Here's, I think your transhumanist buddies will invent an individual score, and by 2028, let's say that 10% of the American population spends most of its waking hours consuming the Kim Kardashian Neuralink stream, where they're actually experiencing Kim Kardashian's life rather than their own. And all of that data feeds into your individual score, which rates like whether or not you're actually a human being with its own independent experience, or just like some kind of receiving station for sense data that comes from, like, you're just kind of an appendage to Kim Kardashian's brain in some way, and like that appendage isn't actually hooked up to any like motor control that makes changes in the world that like actually feed back to real experience. So like, aren't you then just kind of a growth that like is somewhere away from Kim Kardashian's body but is like a secondary processing unit or something? Anyway, so the transhumanists come up with a score based on all the data streams you're consuming that indicates that many people aren't really human at all, by this sophisticated, more enlightened metric of individuality. And at the same time, the AIs seem to score higher on that metric. Many people with power and wealth come to slowly but steadily believe that actually it's the things that score highly on this metric that are really conscious and alive, and that a significant proportion of humanity is actually not human, or not as human as some of the systems that they have themselves engineered, which seem to have richer inner lives than many of their co-meatbags. Isn't this where your philosophy leads, Adam Dorr?
Oh, this is only one episode of there's lots of other ways to get this. Oh, but this, I mean, it would. Yes, there are fascinating paths to dystopian futures that one could explore in the imagination, and we need to, because these are futures that we want to avoid if we can, and getting them into the popular, getting them into the public consciousness and the zeitgeist is important. There's no question about it. There's a role for that, in the same way that entertainment, science fiction, fiction scenarios, they've had a role to play. It sounds silly, but what is the metaphor that we still invoke about the dangers of artificial intelligence? We often hear Skynet, right? And that is just, it's just a quintessential example from the movie Terminator of a science fiction warning us about the risk of inventing artificial intelligence. It's not the only one. There are many, many other instances, but of that, in the canon of science fiction literature. But we do, for better or worse, draw some inspiration and make salient some of these possible dystopian futures. It seems to work better with the dystopian stuff than with the utopian stuff, I'm sad to say. We seem to have a negativity bias. I think that's pretty well documented, actually. But yes, there are all sorts of terrible ways in which this could certainly go wrong. But there are a lot of ways it could go amazingly well and right too. So
yes, amen to that. I guess we have to wrap up, but that was fascinating. I think it was a good topic.
And we ended on a cheery note from you describing the horrors of the.
I had fun getting under your skin, and I hope your humanity score only increases over the next week, so you can bank up some of that humanity.
I will read nothing. I'll just check on social media and just stew on my own thoughts and try to come up with something original. Got to get that individual score bumped up.
That's right. Yeah.
Thanks, guys. This is great.
Okay. See you, mate. Stay tuned.
Take care.